after Thanksgiving, we will have a demonstration. Okay, so please be ready for your demonstration during the Thanksgiving holiday. Based on my experience during the Thanksgiving holiday, there's nothing we can do as an international student. A long time ago, when I was a student, we can use the Black Friday. If we go to the Best Buy or the Walmart or any other shop earlier, then we can buy very cheap, the very nice deal for the electronic device or the laptop. But nowadays you can use the internet online. That will be much better. You don't have to stay overnight. But if you are interested in the bag, like the Coach or the other expensive one, this is a good time to buy. Otherwise, there's nothing special. Especially the restaurant, except the Dunkin' Donuts, the old restaurant closed. So which means it's a good time for you, for students to study and finalize the semester. Okay, so I'm going to start to introduce how to prepare your project to demo. This is based on the email that I sent last week. Okay, so we are going to have a demonstration on Wednesday. Is it Wednesday or?
Monday and Wednesday, 2 days.
I think there's a 2 day I separate into two, right? Yes. I missed one of them. I think that you can check that if your name is not here, that will be the Monday. Okay, this student will present on the Wednesday. Okay, these are the steps because we do not have enough time to take a look at. This is just demonstration. Okay, the URL source and the implementation will be created separately after the demonstration. I'd like to share your implementation with the other students. So how other students implement it. So please be ready for your program. So after you run the program, insert the 3 tuples. So it's a good idea to already make the text file, then copy and paste. So do not spend a lot of time to type each and every record or tuple. So you can insert at least the 3 tuples, or if you have something other interface, okay? So you can use that. Or if you implement based on the SQL, the 92 or the SQL standard, like the insert the into table values, so you can make the statement, then copy and paste. Okay, so during the demonstration. Then retrieve. Retriever is the same thing. So if you have a functionality, if you have just low-level code like the lookup or the others, so you can use that. Otherwise, if you implement the SQL style, the selection like the select, the from, the where condition is totally fine. Also, it will be credited. So you can retrieve such a data, and also you can show the delete. Deletion is not easy in B+3 index. Okay, even I didn't cover in the classroom. Okay, but you can try the deletion. Okay, actually deletion requires the merge. When we have the full of the node, which means more than half, it will be split. Split is easy. Okay, you can copy then left hand side, right hand side. But if the capacity is less than the 50%, you need to merge with your sibling. Okay, so it's not easy to delete. Even though you do not implement the merges, okay, you can just delete the tuple. That will be totally fine. Okay, so you can show how to delete the data. Then you can create the program. This is a simple demonstration during the next week, the week after. It's the next week, anyway. Next week. Okay, the dear student can make the 5-minute video to demonstrate. Then you can upload to the Canvas, but Canvas has the limitation for the storage, so it's a good idea to upload your file to the Google Drive, then send or copy and paste the link for the Google Drive. Then GA and me can watch the video for your demonstration. Any question? Okay, so please work hard for your demo 2, the project 2. Then final exam, as I announced, is December 7th, Monday. Should not be conflict with other classes because it's assigned. based on your registration. So that will be the 10:45 to 12:45 p.m. It will cover, because we didn't have the midterm exam, it will cover all the topics that we have discussed in this classroom. Okay? So the format-wise, it's half of them, less than half, like the 40% to the 50% will be multiple choices, and the others are open-ended question. Open-ended question, if you have done all the class activity, okay, probably you can imagine the modeling, ER modeling, and the relational model, and also mapping, and what else? Index and normalization, and so on. If you have done the successfully so far, including homework, pop-up quiz, everything, probably open-ended question will be fine. Also the multiple choice. So for the multiple choice, many students actually ignore the importance of the multiple choice and didn't pay attention too much during the exam. So usually I give the 4 or 5 the choices. So which means even though you randomly select, it should be the 25%, right? Random choice. Surprisingly, the ratio is less than 50%. So which means the student do not pay attention too much for the multiple choice. So for the multiple choice, you can read carefully the question, and pretty much you can easily answer the question for the multiple choice. Any question regarding the final exam and demonstration? Okay, so we will continue our lecture. Hopefully we will finish the lecture for the transaction and today. So last class we have seen what is a transaction. Transaction is a logical unit of the set of operations. So if we consider the operation or instruction for the basic unit of I/O, that database, not only database, any computer system has a problem. That's the synchronization issue. So because of that, you have learned the synchronization problem in the operating system also. We have the same problem in database, even more serious. So to address the problem, we define the transaction. Transaction always start with the begin transaction and end transaction. End transaction, there are 2 options. One is the commit, another one is the fail or avert. So, however, you never seen such a begin transaction and end transaction in your programming, in your database programming. Most of the cases, such a begin and end transaction are implicitly implemented in the database application, such as, for example, SQL Plus. When you are using the SQL Plus, when you log on the SQL Plus, automatically begin transaction. When you exit, it's automatically either commit or avert, depending on how to set up the configuration of the application. So mostly it's committed, but not always. So these are the transaction used in the database. So that the transaction consists of basically the read and write 2 main operations. So combination of the read and write. Then it start with the begin and end with the end transaction. So database, most important part of the database is it should be stable, consistent. Okay. If I update the data, but if that is not applied because of the power out, then nobody want to use your database system. So that is the most important. Your data, if you change the data, if you update the data, that should be applied permanently. Okay, it's called the durability. We will see such a characteristic of the transaction later soon. But so to achieve such a goal of the database transaction, we will use the undo and redo technique. So undo and redo operation are used for the database transaction. It's not actually not only the database transaction, some of the system also use such a redo and undo operation. It's also used for the recovery technique. What is a recovery? In case database system is failed. Not only system, the transaction level, it can be failed. And also system-wide, it can be failed. Your entire, the IT site can be collapsed. So any kind of the failure, your system should be recoverable. At that time, we need a recovery technique. How can we recover such a transaction, system, or entire site? Basically, it's the undo and redo operation. Redo operation first. Redo operation is when we commit the data, it should be applied permanently. That's a commit, right? I commit the transaction. So I change the data. That data should be applied forever. Unfortunately, database will not write the data after commit to the hard disk drive. It's still in the memory. As you know, the data in the memory, one of the problem is if you do not have power, you will lose the data. Then how can we keep the changed data in the memory? That is a problem. Then somebody may ask, why do we need to keep the changed data on the memory? Why not? We apply to the hard disk drive directly. Why? Why not? If we update the data, if we can update the data in the hard disk drive, secondary storage, then it is fine, right? Then we do not, most of the system do not apply the changed data hard disk drive. Why? Yes? Time. It takes a long time to update the data. Okay, if you update just 1 or 2 bytes, it's totally fine. But if you update 1 megabyte, 1 gigabyte, then it will take much longer time. Because of that, we will update the data on the memory first, then commit it. Problem? We may lose such a data. At that time, we can use the log or journal. In the log or journal, we can keep the statement, update statement. Okay, so update the salary by 10% increase. That is a comment. That is the statement. Then in all the employee's salary will be updated, then committed. Okay, at that time, we can keep the statement, the comment. We write the command only in the log data. Okay, this log data in the secondary storage, hard disk drive. So even though system is a failed, when system is recovered, the transaction, we can check whether such a salary is increased or not. It's supposed to be 10% increase. If not, we can redo operation. Then we can recover the transaction, even though we lose the updated data. Undo is vice versa. Memory is limited. It's fast, it's limited. I do not commit yet, but data is a lot of changed data. So we cannot keep all the data in the memory. At that time, we can apply changed data to the hard disk drive, secondary storage. Okay? Then, even that is not committed, it's applied to the hard disk drive. Then, what if the system failed? When you check the log, there's no command to update the data. But hard disk drive is updated. At that time, you can go back, undo the operation, original data. That is undo and redo. All recovery and all the transaction will be recovered based on these two operations, undo and redo operation. At that time, the log data is important. Because of that, at least you need to keep such a log data when you back up your system. Not only the data itself, but also the log information. Many of the administrators fail to back up the log data. They keep copy and paste the data file or table and so on. But if they fail to copy the log data, they cannot restore the system. Yes?
So is the log data like a data structure or something?
It's not the data structure as a relational model. It's just nothing but log journaling. Okay?
Like comments on.
Yes, comment. Or the web server log. Web server log, if you see the log file of the web server, it will show each transaction where it's logged. It's exactly the same format. Timestamp and what kind of command is executed.
But it doesn't store data in it.
Yes. No, only command. If you keep all the data, so you'd better update the hard disk drive, right? So only command. So if command will be very simple, update the salary. or update the customer information. That how many customer? So 10 millions of it. Then even though you have the 10 millions, in the log is only one command. Okay? So it's basically the timestamp and the information. That is the log. Okay? Then I think we didn't discuss this one, the property of the transaction. So this is starting of the today's lecture. So then, what is the property of such a database transaction? So database should be reliable, even though there exists any failure. And also, when I update the data until commit, it should not be applied. So people define what are the characteristics or property of the database transaction. So that's called the ACID property. First, A stands for the atomicity. Atomicity means, it's as we have discussed, what is the reason to define the transaction? Transaction consists of a number of operations. Okay? However, they should be working together, which means it's a basic unit. Okay? It's an atomic unit. In case of the failure in the middle of transaction, entire the operation should be failed in the transaction. Otherwise, if you commit your transaction, all the operation in the same transaction should be applied. So they work together. All operation in one transaction is called the atomic unit, basic unit of the operation in the database. That is the transaction. So when you are saying that my transaction is not working or failed, that means that transaction, each transaction may have a number of operations, read, write, but they work together. Either commit or the abort. Either successful or the fail. So that is atomicity. Okay? Then consistency. C means it's a consistency. What is a consistency? You should be consistent for the academic performance. Or you should be consistent. The GPA. The performance should be consistent in the sports game. So it's a consistent. So in the database, consistency means, do you remember the database state? The beginning of this class, we defined the database state. So what is the database state?
The current status of
the current state. That includes
data size
schema and data instances. So that is everything in your database. I define the employee as the employee name, ID, and so on. Then we insert the data. That is the database state. So when you operate, when you run any database transaction, that should preserve. It should move from one database state to the another database state. Okay? So for example, when I apply the one transaction, that includes update the employee data. So there is the employee, the schema, and the instances. Then update the employee, the salary, but it's also database, another database state. Okay? So it's a consistency. So that is called the consistency preservation. Okay? That is a consistency. Isolation means when you process, this is one transaction, begin transaction and the transaction. Until the end of the transaction, there might be another transaction, but this transaction cannot see the change of the data. Until when? Coming. Also same thing. If another transaction to this transaction update the data. Same thing. Employee and employee. Even though they are updating the same data or the same table, they cannot see each other until coming. If you allow, it will be messed up, right? So employee 1 to 2, this one 1 to 3. Which one? You cannot. The guarantee. The obvious synchronization issue. So each one, even atomicity, but also It's isolated. However, there are different levels of the isolation. For example, so if the transaction 2 read the data earlier, okay, then the other, one example, the other transaction cannot read the data even. It's isolate very strictly. Even when you read the data, you can lock entire table, even entire the database you can lock. So there might be different level of the locking. Most popular one is nowadays in the database, you cannot block the other transaction for reading and writing. In other words, when transaction 2 read and write the employee data, the other transaction can also read and write the data. Okay? But once this one is committed, this one is for example 3. But this one is committed, then this time is still 3, but after commit it will be 2. Okay? So you cannot block. You cannot block other transaction to the read and write. So that is the current level. So each DBMS has the different level of isolation. The isolation level 1, 2, 3, 4, 5, 6. Okay. So mostly you can use the default level, but the basic idea is do not block any writing. Do not block any the reading. So that is the isolation. Durability or permanency means once you commit, they should be preserved. They should be forever. Even though system fail, even though collapse, for example, the write ahead law that I explained. Even though data is updated in the memory, but fail, system is failed, then we can preserve. We can keep the changed data. So that is the durability or permanency. So it's ACID, the property. This is a very strict and very strong the characteristic of the database. Because of this one, in other words, it's not flexible. Okay? For the transactions, it should be isolated and the consistency should be preserved. Think about the distributed system. Distributed system, so we have the database, same database, but different location. So if we update the data in one side, we need to synchronize. So it takes a time. So it will not be applied right away. We cannot keep the consistency. Also, to keep the durability, we need to log each and every transaction. So it takes a longer time. Think about the Facebook. How many transactions we have? A lot. And also, the Facebook keep only one location to keep all the data? No. Facebook distributed worldwide. So because of that, Facebook cannot keep all this ACID property. Instead, they are relaxed the property for the database. So they cannot use the relational database management system for their database system. Because of that, even though you post a message, sometimes your friend in other country asks, I cannot see your message. Did you upload the message? Yes, I did, but they cannot. It takes a time to synchronize to other. Even though you commit, you post the message, it will not be applied for all. So you lose consistency. It's not consistent database state. Okay? So that will be the main topic of the NoSQL database. Not only SQL or the NoSQL, that will be the relational model. The most important one is this property, especially the consistency should be, and also durability. Because of this one, we need to have the implemented a lot of constraints, primary key constraint, the entity constraint, and what is the foreign key constraint, a lot of constraints. But if we keep such all the constraint database, like the Facebook database, they cannot process a lot of transactions. So mostly we will discuss about such a non-ACID, which is called the CAP theorem. Okay, CAP theorem. Yes.
There was a for isolation, let's say that one transaction is, for example, reading data, and another transaction is writing new data. Once you retrieve new information at different times.
So in one transaction, based on the starting time, this transaction, even though it's a change in the middle, it's isolated. They process based on the database state beginning of this one. It's the same thing. This transaction, even though this one is updated and then read and update, it will be based on this one for this transaction because they are isolated.
So we're going to be reading wrong data because they're isolated.
Yeah. That's wrong. We don't know. Okay, so we promise. So we have the agreement. What is wrong, what is correct, right?
So we're not going to be reading wrong data. We're not going to be reading.
That is the problem of the lost update, or that we discussed at the beginning of this chapter. There are three. The malfunction. Okay, so one of them is a lost update. For example, even though you update the data, it will not be applied to other transactions. Okay. Also, the middle of so it takes a long time to average the salary. What if in the middle salary is changed? Right? Do we need to apply this one, or should it be based on this? Because once transaction is started, it's isolated. We cannot apply the other transactions update, even though committed. Okay? Otherwise, it will be messed up. That is isolation. That's the big problem actually when we deal with huge amount of data. So change it every time, everywhere, but we need to protect the current transaction. So what if the transaction takes 2 days, 3 days? So cannot be applied. Okay. Then when we have such isolated, that's the problem. So because each transaction is isolated, so the basic idea of such isolation is we need to keep the locking of the item, the transaction level, record level, or table level, or database level, locking. So the problem is how to schedule such a transaction. So that is the problem of the scheduling to keep such a database property. So I'm not going to discuss the details of such a scheduling in the database, okay? But the idea is that we need to keep such an isolation level, we need to schedule. Sometimes which one should be running first and which one is later. Otherwise, it will be locked and wait. Okay? That is the transaction scheduling in the database. Okay? I'm going to skip the scheduling part. This is you can set up the isolation level in your transaction. Okay. Like for example, read uncommitted. So for example, if data is not, even though not committed by the other transaction, you should be able to read. This is the very relaxed isolation level. It's not much isolated, right? So, but that may cause the problem. So only commit your isolation level, you can set read commit, which means only committed data you can read in the transaction, or repeatable read, or the serializable. Serializable means even though it's not, the transaction is not ended, but based on by the considering order of the operation, it may be readable. That is a serializable. The next topic, the last topic of the database, advanced database, is concurrency control. What is a concurrency? Concurrent means the same time to access the data. So if we have the single user, for the database system, there might be no problem for the transaction control or the such a concurrency control. However, since we have the multiple transaction, for example, employee data, how many copies of employee data? Only one copy. We don't want to, so far we have designed the database based on what? No redundant information. Why? If you have the redundant information, it may cause a lot of problem, right? So we'd like to have the non-redundant. Because of that, the database, the object should be shared with the many transactions. Because of that, it may cause the problem. That is the concurrency control. Why? How can you keep the transaction management? The basic idea is the locking. So we need to get the lock to read the data. We need to get the lock to write the data. So if we do not manage such a locking, that may cause sometimes deadlock. Deadlock means it's requesting each other, it's waiting forever, or the starvation problem. Some of the transactions may not be processed, so we need to address such a problem using the concurrency control. Basic idea is when you read or write the data, you need to get the lock. Okay? Unless you get the lock, you cannot read or you cannot write the data. Okay? Then how to get the lock is the problem. So most popular approach is the two-phase locking. Two-phase, as name implies, how many phases? Two phases. One phase, getting the lock. Okay? Then once you get the lock of the item that you need, then operate, then release the lock. So getting the lock is the first phase, release the lock, second phase. So it's called the two-phase locking. Problem is how to get the lock. So I need to wait until I get all the lock. Okay? Right? So that's one way. That is a very strict version of the two-phase locking. If you use such a strict locking, sometimes you may not complete your transaction, right? What if he is holding the lock of the employee table, which I need, but the process every time that. So it's a very strict lock. So another way is you can get the lock whenever you need. It's a step by step. It's a basic. But worse, the basic is too relaxed. So you may not get the all of the lock also. So there is another ways that we are going to discuss. So that is a two-phase locking. Okay. The purpose of the concurrency control is to keep the isolation among multiple transactions. Okay. Conflict transaction. That's called the conflict transaction. So conflict transaction means, so when we have the two different transactions, so transaction 1 and transaction 2, okay, and they are accessing the same data. If they access the different data, there might be no problem. They can do whatever they want. One more thing is, one of them, at least one of them, most of them, or one of them should be writing, right operation. At that time, we call this situation as conflict situation. Okay. So conflict situation is we have the multiple transaction and with the shared data, and at least one of them is writing. For example, when we represent a transaction, operation in the transaction, R or W indicate read operation or write operation, respectively. Okay, R means read and W means writing. And 1 means it's a transaction number. And X in the parenthesis is the database item. Database item can be based on the granularity of the database object. It can be column value. It can be entire record. It can be entire table. It can be entire database. Okay, so depending on the requirement. So we have the, for example, what does it mean? Transaction 1, read the data item X. This one, transaction 2, write the data item X. Let's check whether they are conflict 1. So how many transactions? 1 and 2, multiple transaction. Then it's the same data. Yes, and both of them are accessing the X. And at least one of them is writing. Yes, transaction 2 is writing. So that means this is a conflict situation. So conflict, the two transactions are conflict. So conflict situation. That conflict may cause not always, but may cause the problem. So we need to address that problem. That is a concurrency control. What about this one? Is it conflict 1? Check. So multiple 2 and 1, multiple transaction. And they access the same data. Yes, X. And at least one of them, this one, transaction 1 is a writing operation. So this is a conflict situation. We need to address that problem. What about this? Why this is not a conflict? No writing operation. So they can read whatever they want. So without any problem. What about this one? They access this, even though they have the multiple transaction and they are writing, but they are writing different the object. So there might be no problem. They can do whatever they want. It's not conflict. So you don't have to worry about it. So this one, even though writing and share the data, right? It's the same transaction. In the same transaction, you can do whatever you want, right? So these, in case of conflict, you need to do something. So that is the concurrency control. Okay. So to understand the two-phase locking, you need to understand there are two different locks. Anyway, so first locking is the read lock. Read lock is called the shared lock. So you can allow as many transactions as possible for the read lock. Read is also locking. Okay, you need to manage how many transactions are accessing such a data. Okay, that is the read lock. And there is another lock that is for writing lock. Writing lock, how many? Only one. So because that is called exclusive lock. So read lock is a shared lock. The writing lock is an exclusive lock. Only one transaction is allowed. So that is a lock. And unlock means release the item to other transactions. So lock and unlock the operation are needed. So that's the shared lock and the exclusive lock, or read lock and write lock. Okay. In case of the read-write or write-read or write-write, this is a conflict. Okay? And the read and read, there might be no problem. So to manage to implement concurrency control regarding to the lock, we need to manage several the table. So first one is that is called the lock manager. So just like the query optimizer in DBMS. So relational database management system should manage the lock manager. So lock manager is a component to address the problem of the concurrency control. Okay? So when you develop the new the IDBMS, so you need to think about the lock manager. If your system allow multiple transactions. So, however, if you develop the single user relational database management system, then you don't have to worry about the lock manager. Only one user, one transaction for the system. So we are going to implement the lock manager. That lock manager includes the first lock table. So lock table includes the information about the locking per transaction. So for example, transaction 1, access the data item X1. Okay, so read lock, and is there any the other item? Okay, other item that the transaction 1 need? In this case, no. So that is the lock table. Okay. Then this is the operation to get the lock of X. Okay? This is unlock. You can release the lock. And there are two different locks as we have discussed. Lead lock. Main part of the lead lock, you can keep the number of the transaction, number of read. Okay? When you release the lock, if that is a lead lock, you can -1. Okay? Exclude write lock, so you can get the lock. You don't have to count the number of locks because it's only one lock. Okay? Yes or no. So it's locked, then during the unlock, you can just unlock for the exclusive lock. So these are the functions that you need to implement when you develop the lock manager. Okay? This one. Okay. Then there is another operation to simplify the problem. One is the lock conversion. Lock conversion means, so first I read the data item X. I read the employee. Then I decide to update in the same transaction. At that time, you don't have to release the lock and getting the exclusive lock. Instead, you can upgrade the lock from read lock to writing lock. There's another one, downgrade. From the writing lock, you can downgrade to the read lock. That is the lock conversion. Okay? So, finally, we can implement the two-phase locking. First phase is getting the lock that you need in your transaction. And second phase is unlock. Okay? After you complete the operation, you can release the lock. Two-phase locking. Okay? In other words, it's called the growing phase and the shrinking phase. Problem is, okay, we need to decide how to get the lock, how to implement the first phase. There are two ways, conservative and the basic. I mentioned it differently, so I mentioned the strict, but that is actually conservative. Conservative means you need to get all the lock that are required in your transaction first. So get the lock, prevent the deadlock by locking all desired data item. So first you need to get a lock for all the data item in your transaction, then perform the operation, then release it. That is a conservative. It's a very strong level of the locking. Because of that, sometimes you may not get all the lock. You need to wait until you get the whole lock. To address that problem, the basic is, so transaction can get the lock incrementally. Whenever you need, so read the lock, if you get the read lock and read it. Then next, if I need the write lock and get the write lock, then write it. Problem is, it may be conflict with the other transaction. Then, so I'm holding the data item X, and he is another transaction. He is holding the data item Y. But I need Y, he needs the X. We are waiting each other. That is called deadlock. So this basic, the basic approach may cause the deadlock situation. Deadlock is a serious problem in any computer system. You cannot proceed to the next step. So address that problem, we have the strict version of. It's stricter than the basic, but not like the conservative. Conservative is too much strict. Okay, so very strong. You need until you operate the until you perform your operation, you need to get the whole lock, read lock, write lock, read lock, write lock. Sometimes you may not get. Okay, so but basic is too much release. Okay, so it may cause the deadlock. So strict version is in case of the conflict situation, conflict that we define. In case of conflict situation, we need to give up one of the transaction. Okay, so for example, if we transaction 1 for me, transaction 2 for him, in case of conflict situation, we need to decide whether the one of the transaction will be terminated. Otherwise, I cannot proceed. So that is kind of idea of the strict version. So to implement the, I'm going to skip the deadlock problem is exactly the same as that you learned in operating system. Deadlock, the prevention, deadlock detection and resolution, and deadlock avoidance. Okay, so there are the approach for the strict version of the two-phase locking. One is the wait die algorithm, either wait or the die. Okay, die means terminate the transaction. This is almost the same idea but different perspective. So I'm going to explain the strict version of the two-phase locking based on the wait die algorithm. In this case, Ti means it's a transaction. Transaction I, transaction J. And Ts means timestamp. Okay? So timestamp is nothing but sequence number, or it can be the real time. It doesn't matter. Okay? So, for example, if Ts, let's say it's a T1 and this is T2. Then the Ts timestamp of the T1 is a 10, this one is a 20. That means T1 is younger. Okay? Younger means the old process. Older process. Okay? Younger? Older. So less number means it's older process. Longer, the long running process. So at that time, so left hand side is the transaction that caused the conflict situation. So currently, this right hand side, the transaction is running. Then Ts, the Ti request a writing log or something that may cause the conflict situation. That time check whether the transaction that caused the conflict is younger than this one or older than this one. Which one is older? So for example, if Ti is older, okay, so that means less number means older, then wait, okay, until the Tj is completed. Otherwise, if this one is younger, which means started later. So this is a Ti, this is a Tj. So, for example, Tj, the read data item X, okay, this time. Then Ti started earlier, but this time request writing wrong, okay. So currently read wrong, and this one request write wrong, okay. At this time, this is a conflict situation, right? Then check whether Ts of Ti is younger than or older than Ts of Tj. Okay? This one is older. Then we can let this process is waiting. Okay? Until this one is completed. However, if Ti is this younger, then cause the conflict situation. At that time, we avert this transaction. Why we avert that? Because if we let this one is waiting for this one, then may cause the deadlock. Okay? So we are going to keep any transaction that is older only. Okay? Because it's a long-running job, so we try to keep. Even though conflict situation, one of them, there might be. So for example, if my transaction and his transaction cause the deadlock, one of them should resolve the problem, right? If both of them are waiting, they may cause a problem. So which one is the waiting? Older one is waiting. Okay? If I'm the younger, so started later, then we will terminate that younger the transaction always. Somebody may be curious. Does always the younger cause the problem? No. We decide one of them. Okay? We decide one of the transaction as the resolution of the deadlock. Deadlock not always happen, but may cause the deadlock. So we always, if conflict situation, conflict does not mean the deadlock, but conflict situation, conflict transaction may cause the deadlock. So we decide which one is whether the transaction that caused the conflict, okay, is it younger or older? In case of older, keep waiting because it's a long-running job. Otherwise, terminate, so die. That is the reason, wait or die. The next one, when the wait is opposite. If the transaction that caused the deadlock is older than the terminate. Otherwise, keep waiting. It's the same idea, but it's like a different one. So this is a wait time algorithm. We will see the example of that. So two-phase locking. So I already explained about the basic. So there are two phases, locking phase, unlocking phases. So two types of lock, the read lock and write lock. So in case of conflict, they may cause the deadlock situation. So we need to address. How to address? So we are going to implement a strict version of the two-phase locking. So we need to manage the several information. One is the lock table. Lock table is that keeps the for each transaction we are going to keep the item and the lock state, and also transaction table for each transaction we are going to manage the transaction ID, timestamp, and transaction state, whether this is active, blocked, aborted, committed, that we have seen before. Okay. So these are the implementation of the operation that we discussed. Then we are going to use the wait-die algorithm. So this is an example to understand wait-die algorithm. So lock manager manages the two tables. One is a transaction table for each transaction, and ID, timestamp, and the state of the transaction, and any item that are held by the transaction. And also lock table and for each item, what is the read lock, or write lock, or exclusive lock, and which transaction is the holding, and which other transaction is waiting for this one. And these are the operation for the how many? 3 transactions. List of the 3 transactions. B means it's a begin transaction. E means end transaction. So we can understand the sequence of the transactions. So begin transaction 1. Okay, this one, what does it mean? Transaction 1, read item Y. Okay, what does the transaction 1 need? Getting the lock first. Okay, so you need to check the lock table whether Y is available. Something like that. We will see one more later. What does it mean? So transaction 1. Right, the right lock or exclusive lock for item 1. Also this time it's the same item. Instead of releasing the lock, getting the lock, we can upgrade the read lock to write lock. What about this? Transaction 1, read data item C. And this one, begin transaction 3. And this one, transaction 3, read lock Y. Something like that. So we will see whether that may cause the problem or not. In case of the problem, conflict situation, how to address that problem. So start. The transaction 1 begins. As I said, the timestamp can be the real time or it can be sequence number. Okay, as long as you can realize which one is earlier, which one is the later, is fine. So we need to update the transaction table because it's a new transaction. Transaction ID is 1, timestamp 1, and the status is active, right? So this is current information. The next, transaction 1, read data item Y. Then check the lock table. There is no information about the locking, which means transaction 1 can get the read lock. Then update the lock table. For the item Y, it's a read lock or the shared lock, and by which transaction? So transaction number 1. And also you need to update the transaction table. Transaction 1 is holding data item Y. Okay, so this is a current the status. of the system. Then, transaction 1 requests the writing lock. Okay? At this time, it's the same item, so we can just upgrade to the write lock from read lock. Then it's the same thing, everything is the same. There's no problem, there's no concurrency issue, there's no the deadlock issue. And this is another lock by the transaction. It's a read lock on Z. Check the lock table. Is there any the Z? No, there is no the lock, so the transaction 1 can get the read lock for the data item C. So that is the this, and also update the transaction table. So transaction 1 is holding Y and Z item. Then transaction 3 is started. You can assign the next number or the timestamp, it doesn't matter. So timestamp, the 3 is a TS2. Don't be confused with the transaction ID. Okay? This one is the 2 and active. And this one, is there any lock? No. No lock yet. Then transaction 3 requests the read lock for data item Y. At this time, check. Lock table is already held by other transaction. We need to check conflict condition. First, multiple transaction. Is it multiple transaction? Yes, transaction 3, transaction 1. Then, it's the same data item? Yes, it's a Y. And is there any the writing? Yes, it's a the transaction 1 is holding the data item Y with the write lock. It's a conflict situation. Conflict situation does not mean it's a deadlock right away. It may cause the deadlock later. So we need to address that problem earlier to keep the concurrency control. Okay? How can we? We learned wait-line algorithm. So check. Who caused the problem? Transaction 3 caused the problem. Okay? Then this one. Which one is transaction 3 is older than the T1? No, it's younger. So younger will be die. Right? That is the wait-line algorithm. In case transaction 3 started, like for example this one is here, then this probably like this. Right? At that time, this transaction can wait. Okay? Until the other transaction is completed. But here, this one is the younger, okay? This one is older. That means we are going to avert this transaction. Why we avert? For future deadlock situation. Okay? So this one is averted. Okay? Then this transaction 3 is averted, and still the lock table is held by 2 items are held by the transaction ID 1. Okay? Any question so far? Then next, this one is already averted, so you don't have to do anything. Just averted, and transaction 3 averted, so nothing. Then transaction 1 getting the lock. It's an exclusive lock for the C. It was the shared lock, so we can upgrade, okay, and update. Then end transaction 1. End means it's a commit. So commit means the release all the locked items. So nothing, lock table and nothing on the transaction table T1. It's a committed. Okay, then B2 is started. B2 is read. B2 is started. Timestamp 3. Timestamp 3 active, and it's a read lock for the data item X. Right? Read lock. And write lock, upgrade. There might be no problem, no conflict situation, and averted. The transaction 3 is already averted before, right? So you don't have to do anything, and end is already averted, nothing, and read lock. For the it's a transaction 2, read lock on the item Z, okay, and write lock you can upgrade and end. So you can avoid the deadlock problem. We are not sure, we don't know whether this may cause the deadlock or not. But however, for safety, for future, so we are going to avert one of the transaction, either wait or not. So if we apply the wound weight, it's the opposite. In this case, the T1 will be the terminate period. Okay? So that is a two-phase locking with the strict version. What about the operating system? Did you take the operating system class? Some of, right? How does the operating system, current operating system, handle such a deadlock situation?
There are different ways.
Different ways, but most popular one is
I think priority.
ignore, right? So actually the operating system does not care the deadlock. It may happen, then who is in charge of to serve that deadlock? Application and end user. So that is the reason from time to time you need to Control C. Or using task manager you need to terminate, or using kill command you need to terminate the process. Why? As you can see, it's very complicated. You need to check every time whether it calls the deadlock or not. You need to manage the lock manager and table operating system. If you need to handle the deadlock every time, how many processes? So many processes. So it's an operating system ignore any deadlock situation. In case something happens, each application is in charge of to address the problem. Why database manage such a lock? Because the database, as we have seen in the property ACID, especially the concurrency control, is very important. If you let the deadlock happen, then your system will be locked. Your transaction will be wait, which is not allowed in the database system. Okay, it's not acceptable in the database system. Because of that, we are going to apply the two-phase locking to address the problem of the deadlock, in other words, a conflict situation. Okay, that is the concurrency control in the database. Any questions? There are several other ways to keep the concurrency of the database, but I try to finalize the concurrency control with a multi-version concurrency control. This is the most popular nowadays. So what is this? This one? It's a computer. And this one? It's a memory. Okay? Then inside the memory you have process and whatever you want. Then I try to connect we have the secondary storage, and we have one of the application of this computer is a database management system. We have, for example, Oracle database. Okay, so what happened when you start your database system? What happened? What does that mean? The starting your database. It's not only for the Oracle database, the MySQL and what else? The SQL Server. What happened when you start your database? What does that mean? What happened when you learn the program? Project 1, Project 2, what happened when you execute your program?
We connect to a database server at particular port.
Not very complicated. Just you have project in your software engineering class, right? Then you start your program. What happened?
They occupy the space in memory.
That means it's a creating process, right? Any program, when you execute any program in your computer system, when you start that program, that means creating process, okay? So that means your program, like there's MS Word, When you start this one, this code will be loaded into the memory. That means it's creating processes. That's how the application program is working on top of the operating system. Same thing. When you start the Oracle database, SQL Server, MySQL, what happened? There might be the program. Oracle has oracle.exe or the Oracle, the shareable, the object. That will be loaded into the memory. Not only that, but for example, log manager will be processed. And what else? Query optimizer, query processor, recovery manager. If you have a lot of components, that will be started. Sometimes some of them are combined into one process, or some of the DBMS combined into just one process, or several processes. So a number of processes will be started. For example, Oracle has the database writer, DB writer, log writer, and some other processes. That's the same as other applications. Because of that, DBMS is nothing but application program from the operating system point of view. Okay? So that means when you learn the database a lot, you need to study operating system or computer architecture network because it's application program. Anyway, however, there are slightly different things comparing to other application program in this database. First, when you start up your database, process will be started, created. The next part, reserve a lot of memory. That's called sometimes SGA or the reserved memory system global area or the reserved memory. So you are going to reserve huge part of your memory when you start the database management system. Why? Why do you need to reserve the memory? For cache purpose. Okay. Anyway, database, as we have discussed before, file system approach, database approach. Actually, file system approach is faster. Okay. However, using database is even faster when we access the data. How? One of the ways is it uses a lot of memory. It's a reserved area. So when you connect the database from the client, you select the employee. Name is A. What happened? This is an employee table. Then one database block A will be loaded into this reserved area. This is called database buffer cache. Okay. So this is how it works. And return A. So A will be returned. Then I try to update A to B. What happened? So based on the concurrency control, you need to get the log, check the log manager. So ignore that part. Okay. Then first you need to check the buffer cache. If there exists A, you can update in the memory. Okay. Otherwise, you need to select the data from the storage and bring into the memory. So that's the A. Okay, then update. Like this one. Instead of updating in the memory directly, we will copy. Then update the data, A to B. This one is called old image. This one is called new image. Old buffer, new buffer. Old image, new image. Okay? Then sometimes it's called a dirty buffer because it's changed. Then until committed, this old image will be served for other transaction. Okay? Then even though it's not committed, this new image will be used for current transaction. Then we can keep the what? isolation. Okay? So how many version? Multi-version. If there is another transaction that update A to C, but not committed, access this one and update C. Then this will be used for what? This another transaction. How many version? Multi-version. This is a multi-version concurrency control. So you can manage the multi-version of the data. Okay? Then you can keep the concurrency. It's the most popular nowadays. Multi-version, the concurrency control. Okay. Why don't we consider write ahead law that we have discussed? So this one is the and committed. Commit means B is the current data. Do I need to remove the before image, old image, after commit? Yes or no? It's a commit. You will keep, not forever, but you do better. The database will not remove old image, before image. Why? For example, there's another transaction one that started before this transaction, update transaction. This one, select the name from employee. It takes a long time up to here. Even after commit, it takes a long time. It still needs old data, new data. Even though committed, this transaction needs old data. It's committed. However, we need to keep the old version of the data. To keep what? Isolation. So multi-version approach is a very convenient way to keep the different isolation. How long do we need to keep? How long? We cannot guarantee whether there is just a problem at the transaction one. Sometimes it's very busy, we need to hold the space. So if needed, we can remove. Then use the free buffer. Then what if this one is removed before it started earlier but still running? What is the before image gone? That may happen. So one of the popular error message on the Oracle database is a 1555. It's a snapshot to old. So it needs old image, but it's already flushed. Then there's no data, the before image. Then this transaction will be automatically terminated. So that's because of many of the developer and the administrator do not understand what does that mean. Solution, you need to learn this security again. But if you understand why it causes a problem, then you can. There's another way you can increase the temporary space, buffer space. That is a multi-version technique for the database concurrency. Okay, so the other part, I'm going to skip the details. Okay, so that is the end of the lecture this semester. So I think I should say thank you so much throughout the semester, especially for the undergraduate students. So we cover, because it's a cross-listed program, I should cover a lot of advanced part. Okay? So I definitely thank you for understanding and following. But it will definitely good for you guys and also graduate student. From time to time, I have some quiz and pop-up quiz and the class activity. But hopefully you enjoy the advanced database. Before I finalize, I'd like to hand out the